Hey everyone, it's Matthew, and I have something really incredible to show you today, and I think we'll just get right into it. Um, while this is loading up, I want to quickly say that while I rediscovered this mostly on my own, it is very similar to work done by Captain Wutax and Lucky Typhlosion around the time that the 1.16 snapshots were releasing. I think I've gone a little bit further than them, but just know that I'm not the first person to think of ideas like this. And I also quickly want to acknowledge Supercoder79 for her help when I was working out all the little details of this. Okay. Now let's get right into it, I think. So what I'm going to show you is going to seem insane at first, okay? So we're just going to do it once. So this is a clay patch, okay? This is its center, and we're going to count 6 blocks. So that's 1, and we're going to 3, 4, 5. Okay. So that's 6 blocks. We'll explain why I moved in a moment. And we're just going to dig down here. And there should be diamonds once we get down to diamond level. And there they are. Alright. So by now you can maybe guess what I'm going to show you. Okay? Because every single one of these clay patches in a swamp can lead you to diamonds. Let's do another one. Okay? This one. Right here. This way is positive Z. So we count out 6 blocks. This one's on a chunk border, so it might fail in this situation. If it's not here, I'll have to teleport. I'll have to move over 16 blocks, and then it will be there. But it should be here. There it is. Okay. And let's do one more as an example. Let me try and find one that doesn't cross a chunk border. This one maybe? Yeah, okay. So this one, find the center. And then I count over 6 blocks. Okay. So, by now you're probably wondering how this works and if it always works. And the answer to, I'll explain the how by the end of this video. I do quickly want to warn, some version of this always works on every seed. But it's not always 6 blocks. So on this seed in particular, I'm counting over 6 blocks. On most seeds, 7 blocks is what will work. Well, really, on most seeds it's 6 or 8, but we'll talk about that in a moment. But every seed basically has a number like 6, which you can move over in the Z direction and dig down to find diamonds. And so sure enough, with all these clay patches, every single one of them represents a diamond ore. Hey, so sorry, I had to take a brief break. This is the same seed as before, and I'm now going to show that it works with these gravel patches. In biomes other than swamps, you can use these gravel patches. You'll often see these in rivers. And you can also use these clay patches, which you'll also sometimes see in rivers. So again, we're going to find some diamonds. So on this seed, and in fact on most seeds, you go -2 from gravel patches to find diamonds. So let's see if this works. Should be diamonds soon. Ah, there they are. Okay. And it looks like, I don't know what the clay number is off the top of my head for this seed, but also it's not critical that you know your seed or whatnot. Looks like it's two or three this way from the center of clay. So we can try and use that now. Here, so here's clay. The size of the gravel patch indicates how deep the diamond ore will be on this seed. So even just looking at this gravel patch, I can tell you that this diamond ore probably tried to spawn in the bedrock. So it's probably not worth it to check that one. This one, on the other hand, the diamond ore is either tried to spawn very high up or at Y0. So we have a pretty good chance of some high diamond ore. But it's on a chunk border. So I'm not quite sure if this will be correct. There's a certain chance that it could be... There's a certain chance that it could have crossed over to the other side of the chunk here. So if we don't find anything, we'll dig down there. But, there it is. Okay. Okay. So, but by now I think you should be convinced that this works. I've shown pretty much all the practical examples. We can try doing clay. It looks like clay is maybe -2 on this seed, but whatever. There's also a number that you can move from the clay in non-swamps. It'll be different for swamps and for in swamps. So yeah, let's quickly review the actual numbers. Okay. So first of all, I want to stress with chunk borders, if, say, you find on your seed, you build over 8 blocks from clay to find diamonds, you should never cross a chunk border. So right here, you shouldn't go through this red, you shouldn't go that way. But what you can do is you just teleport over to the other side of the chunk and keep counting, and this will work. So just keep that in mind. The other thing to warn about is that if it lands like exactly here, there's a chance that it's, or even like nearish, like maybe sometimes if it's 1 block off. But if it lands nearish, there's a chance that it is over here, because the correct number isn't like exactly 8 most of the time. Most of the time it's like move 8.2 blocks over. But you can't measure the clay starting coordinates more accurately than a block, so it's kind of hit or miss. So just be warned that on chunk, if it hits a chunk border like this, you might be in trouble. Yeah, so I'm going to give you numbers that will work on the highest percentage of seeds, and I'll give you the possible numbers for each seed. So that is... I'm going to give you a number which, if you always build this much out, it'll work like maybe 75% of seeds. And then I'm also going to give you numbers where like these are the possible numbers for seeds. So if you just have a survival world, you don't know the seed of it, you can still measure a few diamond ore and a few clay. And then you can make a good guess that on your world 6 is the best number to build over, or 8 is the best number to build over, right? So we're going to review. So the first set of numbers is for non-swamp clay. So if you have a clay patch that's not in a swamp, for diamonds, you're going to want to build 2 blocks over in the positive Z. For iron, and you're going to have an 81.25% chance of 2 blocks over in the positive Z working for diamonds from non-swamp clay. For non-swamp clay, if you want to find an iron vein, so I included this for maybe speedrunners, but you can build 5 blocks over, and you've got a 62.5% chance of iron in the column if you build 5 blocks over. And also for speedrunners, if you have non-swamp clay and you really need gravel, you can dig down in the center of it and you've got a 31.25% chance of hitting gravel. I'm sorry, there's not much I can do about gravel. I think some UHC players might be interested in gold ore as well, because you can predict multiple ores. I think it could be interesting for competitive Minecraft to know where essentially full diamond armor and 10 gapples are, just by like writing down some swamp clay coordinates. But I didn't bother writing the gold numbers here. I might put those in the description. But in theory, gold should work too. At the least, the first gold vein in a chunk. Yeah, that's the other thing. This iron vein, this is just the percent chance of finding the first iron ore. There's 20 iron ore in a chunk, so maybe this isn't the most useful. But it's got if like you dig underneath the larger clay circle, you're very likely to hit surface iron for some definition of surface. Okay, so the next patch, this is gravel patches in rivers. So we just saw 14. You can also use -2 because, 14 is congruent to -2 mod 16 for diamonds. And then you can build over 2 for iron. So that's 56.25% for the iron, 75% for the diamonds with river gravel. Oh, and I forgot to make this table for the non-swamp clay, but whatever. So these are the actual possible offsets for gravel. So as established, 75% of seeds have one that is 14 long, right? So that's pretty crazy. And that's also -2, right? So you could also have just built, you could have built like that. That's probably easier. Just go in the -z instead of +z. The last 25% are weird. You should build over 8 blocks on the last 25% of seeds. So if you're not finding the diamonds when you build over 14, you should try building over 8. But the catch with this batch of seeds is that if you're on a seed where you have to build over 8 from gravel to find diamonds, it's only going to work in half of all your chunks. It's going to work in like a checkerboard pattern. So you should try like building over 8 here and building over 8 here if building over 14 is not working. And try a bunch of chunks, because sometimes the diamond like tries to spawn in bedrock, or tries to spawn in a dirt patch, or tries to spawn in a cave, and then you won't see the diamonds. So just be warned that it can fail that way. But yeah, so if you don't have a seed that does where 14 works, then you have one of these suckier seeds. And the final thing that works is the swamp clay, or the first sand in a chunk. And for this one, you can build over 7 blocks, and that will work on 87.5% of seeds. Now, this 7 blocks is slightly misleading. In fact, it's that 50% of seeds are 8 blocks, and 37.5% of seeds are 6 blocks. And then, but 7 is right in the middle of 8 and 6, and diamond ore, like, ore is always biased to the negative direction. So, like, this is where an ore on the 6 would spawn, and, like, this is where an ore on the 8 would spawn. So, if you dig down at 7, you'll be able to see both ores, irregardless of what type of seed you are on. But if you then realize that, like, okay, my seed's probably a 6 seed, you can then dig as if it's a 6 seed, and you'll get slightly better results. But 7 will work really well on most seeds. For iron, 10 blocks, 68.75%. And then for gravel and swamp clay, build 4 blocks in the +z, and that'll give you 37.5%. And yeah, same deal with the gravel over here. The final 12.5% of seeds, you should dig down like directly in the middle of the clay, but it's only going to work in 15% of chunks. Okay? And then the final thing that I'm going to mention is that the size of the gravel patch and the clay patch indicates how deep the ore is. So these are the sizes of gravel patch. Like this is radius 2, radius 3, radius 4, radius 5. This clay is radius 2, radius 3 or whatever, little and big. And so if we look over here, if you're on a seed where building over 14 works, then this is how the sizes work out. And there's similar sizes for like the other types of seeds too. But if you're building over 14, then radius 2 means that you should go, means that the diamond ore will be between Ys 5 and Y8. Radius 3 is 9 and 12. 4 could be Y13, 14, 15, or 0. It sort of wraps back around down. So there's a small chance that you won't find the ore if it's a radius 4 because it's going to try and spawn in the bedrock. And 5 is Ys 1 through 4, which also is going to try and spawn in the bedrock. So you're going to lose some ores in bedrock or behind bedrock if you dig down underneath radius 5 gravel on most seeds. For diamonds specifically. For the other types of ores, it's going to be different. I'll try and put a table in the description which summarizes all this info for all the ores and all the different types of patches. But yeah, but you get the gist. So we know that like this indicates diamonds on this seed. This patch indicates diamonds from Ys 5 to 9. This one's like 9 to 13, and then yeah, you get the drill. And okay, that's about all that there is in the tutorial section. We're gonna quickly explain why this works. Okay, so we're gonna quickly explain why this works. So I first want to give a key overview of just sort of intuition for why it should work at all. The rough gist of it is that inside the Java programming language, there's something called java.util.random, okay? And so this is the core random number generator used by a lot of the Java programming language and a lot of Minecraft code, okay? And roughly, Java random has a major problem, which is that to start up a random number generator in Java, you have to give it an initial number, okay? So we're going to represent that with a little arrow, and that initial number is called the seed. Okay, it's not just the world seed of Minecraft, though. This seed could be any number, and indeed, Minecraft has thousands of random number generators inside it, which all get seeded with different numbers. So what's going on here is that the diamonds are getting seeded with a certain seed, we're going to call it S, plus 60,009. And the other stuff, the patches, are getting seeded with seed plus 60,000 and then either 10, 11, or 12 down here. Oh, wait, no, never 10, actually. 10, anyway, 10 never happens. 10 would represent lapis, but you never really see lapis in a useful way. But okay. And so the rough idea that's going on is that this Java random has what I consider to be a flaw, which is that if you feed it two numbers that are very, very close in numerical value, the outputs of the random number generator of the one seeded with, say, seed plus 60,009 and seed plus 60,011, their outputs will be strongly correlated, and we can use the outputs of one to predict the other with high accuracy. And so that's all that we're doing here. So now let's break into the nitty-gritty of why that is and why it works the same way everywhere on a seed. And yeah. So we're going to introduce a few things very quickly. If you've not seen this stuff before, I'm sorry. I don't know how well I can do without getting you lost. But I'm going to be writing numbers in hexadecimal with a 0x in front of them. So I'm going to write stuff like this. So this is a hexadecimal number. So that's what the 0x indicates. This is how you indicate hexadecimal in programming languages. If you're unfamiliar with what hexadecimal is, I'm afraid I'm not going to explain it to you. I am also similarly binary numbers. I'm just going to write out as like 1001. You know, if it only has ones and zeros, chances are I mean base 2. Again, sorry, but I'm lazy and I'm throwing this together late at night. Okay. And then the final thing that I'm going to introduce is this symbol. I'm going to use this to mean XOR. In a programming language, you might see a caret, but I find that people on YouTube tend to think that the caret means exponentiation. So we're going to be using the O plus as our XOR symbol. And if you're unfamiliar with XOR, it's an operation on binary digits. So if you have 0, 1, like this, 0, 1, 1, it puts out a 0 if the two digits are the same. So 1 and 1, so 1 and 1, those two are the same. So their XOR is 0, and 0 and 0, their XOR is 0, because they're the same. And then if they're different, you get a 1. And we define XOR for list of numbers, for numbers bigger than 0 and 1, like say like this. So these are in binary, by the XOR of their binary digits bitwise. So 0 and 1 gives us 1, 0 and 0, that gives us 0, 1 and 1, that gives us 0. And so that's XOR. And the main thing to understand about XOR, well, XOR has a few nice properties. I don't think we need many of them here. So we'll skip listing them for now. Just understand that this is how it's defined. It's just another operation. Don't be too afraid of it. Okay, so how does Minecraft give a seed to the random number generator? So recall, Minecraft has an instance of the java.util.random object, and it wants to use this Java random to make diamond ore. Okay, so what number does Minecraft feed to this random number generator to kickstart the diamond ore? And the answer is that it uses a formula of the chunks coordinates and the type of ore it's making and the world seed itself to seed the diamond ore. So let's write out the formula in its full glory. So the formula is 16 times the x chunk coordinate times, we're going to just write f of the world seed. Let's call the world seed w. F of world seed plus 16z g of w, so another function of the world seed. And now all of this XOR the world seed. Okay, so this part right here, this is important on its own. You might have seen me talk about expressions which look like this on the channel before. This is just what I would call the decorator hash, or the population hash, excuse me. But now, Mojang doesn't want to use this to make everything. Because if, say, they were making diamond ore, they fed it this formula, and then they went on and they then made lapis ore, and they used the same exact formula, then lapis ore and diamond ore would try and spawn in the same spots for the most part. Or at least their x and z coordinates would line up, probably. Actually, lapis is a terrible example for that, because lapis is a weird and broken ore. Let's go with diamonds and gold. So what Mojang does is they add a salt. So plus salt. Okay, and that's what this, and so this salt is 60,009 for diamonds, and we'll go with, it is 60,011 for swamp clay, right? And so we can see that diamond ore and swamp clay are going to use roughly the same number in the same chunk. But now it gets even better for us, okay? So I'm going to quickly remove this over here. Let's get into how we can determine the exact values to add to our clay coordinates on the seed, and why this thing works on every chunk. So first we're going to show why it works on every chunk, actually. Okay? And this is because we can consider this whole formula, 16xf plus 16zg x or w plus salt. Okay? Think about the bottom 4 bits of this green underlined portion of the expression in binary. Okay? Because this here is a 16, and because this is a 16, the bottom 4 bits right here are all going to look like zeros, and then we're going to have some upper bits. But the key point to remember is that this thing ends in zeros. Okay? You got that? And now, check this out, right? Because when we XOR this with world seed, right? Let's say that the world seed is equal to, let's make up some bottom bits. The example that I gave in the video earlier ended with 1110. Okay? And not only that, and then also has some upper bits, right? So it's not quite this small when written in binary. It's a 64-bit number, of course. So now, with this knowledge, let's take a look at let's try and compute what this whole portion of the equation is going to be. Okay? So we know our bottom bits of our world seed now. It's going to end in dot, dot, dot. Why won't this let me draw dots? 1, 1, 1, 0. And we're going to XOR it with all zeros. And anything XORed by 0 is that thing back. So 0 XOR 1 is 1. 0 XOR 1 is 1. 0 XOR 1 is 1. And so we know that this blue part of our equation, right? This part up here, this is going to end in 1, 1, 1, 0. Okay? And we can go even further. We can take our 60,009 and we can compute the bottom 4 bits for that 60,009. And likewise, we can compute the bottom 4 bits for that 60,011. And the key point to remember is that we don't care what the values of x and z are, because these bottom 4 bits are going to stay the same on every single chunk coordinate in the world. Now, the only way that this can break is if, when we're doing this adding of the salt, so let's say we do 1, 1, 1, 0 plus the diamond salt will be 9 mod 16, and we would get 1, 1, 1, 0, and we would get a carry, right? Because 1 plus 1 is 0, but you have to carry the 1. And if we add clay, we're also going to get a carry. And all that matters is that you get a carry with both salts, or you don't get a carry with both salts. As long as that happens, you're golden, and it will work everywhere on the seed. If one salt gives you a carry while the other doesn't, that means that your prediction is only going to work on half of the chunks, because those are the half of the chunks where that carry then doesn't matter for changing the upper bits. But in this case, we're actually going to find that plus the clay salt will end with this, and we're going to find 1, 0, 1, 0, 1, 1, and we do have a carry. Okay? And so the overall result is that we have two things. Both, the clay salt is just the diamond salt plus 2, and we know the bottom 4 bits and whether or not both of them had a carry for a given seed. Well, if you give me the number. for the seed. If you don't know the number for the seed, again, you have to just make measurements and guess what you think the last 4 digits are. But that's really much easier than it sounds. I showed you how to do that earlier. So let's see why this matters, okay? Because now we have to unpack how these numbers get put into Java Random itself, okay? So the first thing that I'm going to show you is that random itself is very simple. It just has an internal number, which I'm going to call x here. So let's draw x in a box. So that's inside the Java Random object. And it's called a linear congruential generator. So it updates x as follows. It multiplies x by a constant a. It then adds a constant b. So in Java, a is equal to 0x5DEECE66D, and b is equal to 0xb, in fact, which is just 11 in decimal. So key takeaway there is that b is very small. Well, that's not so key for this video, but it angers me that they made b so small. A is also quite small too. Actually, keep that in mind. Oh, yeah. This entire thing is mod 2 to the 48. So the x here is only ever 48 bits. If, when multiplied by a, x grows to be larger than 48 bits, the upper bits of x will just be chopped off. So x is never more than 48 binary bits. So, okay. Let us, if random just took the number that you gave it and then used that to do the randomness, then this trick would be much easier. So I think it's informative if we pretend like that's the case. So, okay, looks like I have some room in the upper right, so let's pretend up here. Okay. So remember, diamonds output some number s. So this is the diamond seed in a given chunk, okay? And the clay seed in that chunk will be s plus 2, because diamonds are something plus 60,009, and clay is something plus 60,011, okay? So now, if these were the numbers that Java Random used, then we would have a times s plus b as the first number that Java Random spits out, whereas the clay would get a times 2s plus b. Okay? And we'll notice that if we expand this out, we get as plus b plus an error term of 2s. 2a. Actually, it's very important that that's a. 2a. And the key thing is that we already know the value of a, right? It's in Java Random. I've already shown it to you. We already know the value of 2. So if Java Random just used these numbers, we could just add 2a to the number that we measure for the diamonds and understand the clay. And it goes the opposite way too. We could subtract the subtract the 2a from the clay and get the diamonds, right? So that means that the clay seed number 1 is equal to diamond seed 1 plus 2a. And so this would be, and so what you would then do is you figure out, okay, what seeds put the clay block at this coordinate, and then you just subtract 2a off of that set of seeds, and you get the set of possible seeds the diamond seed could have been, which in turn corresponds to just one coordinate on the map. Well, really, it's kind of like 2 coordinates, because this 2a error term might not be an integer value in-game. However, if you remember, we actually got very lucky here, because if you remember earlier when I mentioned that clay was small, it turns out that the very first seed out of these generators, which does the x coordinate, the error is usually about this small, so about 2a, or sometimes 3A, 4A, whatever. Whatever it is, it's very small in comparison to 48 bits. So the result is the X chord will be the same almost always, like 99.6% of the time or something. So this is incredible. It means that we only need to care about the z coordinate. And to care about the z coordinate, you would calculate the error term the same way. So you'd then take the output of this formula. So you then take the outputs of the two formulas right here, and you do a second call. And so that second call would be the seed corresponding with the z coordinate. So you'd compute like a times this plus b, and a times this plus b. And you'd come out again with that the clay stuff is some constant plus the diamond seed. And then you can just subtract off that difference. You subtract off that error that will be there, and you get the difference in seeds. And that's how I calculated the 6 blocks movement on the seed that you saw me doing earlier. But of course, we're not quite so lucky. Like, this would be a utopia, right? If this was how Java Random was fed random numbers, because this would make this work on any seed, right? Like, the seeds could be different by 20 billion. And you could, as long as you knew the difference between the seeds going in, you could predict their differences on every call in the future. And we're not quite so lucky because Java Random pranks us. Java Random pranks us by if you call this the actual seed used by random, which we'll just call real, is equal to the original seed XOR this 5d constant again. So this is, they reuse this. It's both the sort of initial scramble for the seeds, and it's and it is the multiplier in the LCG. And so this is the actual seed that is used, okay? And so if we look at what this is going to look like, so this is going to end, this is going to be a bunch of bits, and then it's going to end with what, 0, 1, 1, 0, 1, 1, 1, 0, I think. And so we're going to XOR our seed, which, let's see, we have said ends for diamonds, we have said ends in 0, 1, 1, 1, and it has some bits up here. And the key thing is that we know that these upper bits, besides the bottom 4, we know that these upper bits will be the same between diamonds and clay. And that's why that arithmetic carry that I mentioned before is really important, which is that if one seed has a carry of 0 and the other has a carry of 1, then that's going to interfere with this XOR. Because that 1 could potentially like carry more all the way up here, and then all of a sudden you're flipping a bit, like, I don't know, maybe you flip this bit. And then suddenly, after you do this XOR, a bit is flipped that wasn't what you would expect, and suddenly your seeds aren't different by 2 anymore, but instead they're different by like 34 or something. And so that's always terrible. But in this case, as long as we know that that carry didn't happen, we can compute what the XOR will be on both seeds, and then we can find out what the real difference in seeds used by the generator will be. And in this case, it does come out to still be 2. On other seeds, sometimes, at least I think it still comes out to be 2. I haven't 100% confirmed that. On other seeds, if you were to do this, On other seeds, if you were to do this, there's a potential that that this carry just ruins your day. And there's potential that some of these bottom 4 bits would have flipped, but all in a predictable manner, so you'd be fine. Because you know what the bottom 4 bits are everywhere on the seed. And so the seeds which only work 50% of the time, they've got some nasty carry problems. So they've got one carry different than the other. So sometimes this bit down here is different from what you expect. But if you just assume that, no further carries happen, which happens in 50% of chunks in a checkerboard pattern, then you're fine again. So it's sort of acceptable to me to have only 50% of chunks working. But yeah, that's the explanation. Thank you for watching. Please, if you watched this long and you made it and you felt like you're understanding, even a little bit, please consider subscribing. I find stuff like this a lot. I have a lot of videos that I should be making that I'm not making because I'm lazy. I'm trying to be better. Maybe subscribe, motivate me to publish the cool stuff, because I promise I still have cool stuff. And yeah, thank you.